Hello, we have another installment of the COVID-19 series here. All right, I'm going to do an example a lot like problem 5 in your latest web work, the nonhomogeneous set. We have this linear nonhomogeneous ODE with constant coefficients, y double prime plus 4y prime plus 4y equals 18e to the t, with those initial conditions, y of 0 is 4, y prime of 0 is minus 1. All right, so step 1 of this three-step process is find the general solution, which is y equals yh plus yp, right? Remember, yh is a solution to the associated homogeneous equation when the right-hand side is 0, and yp is a particular solution, or just a solution, a measly solution, any old solution, to the non-homogeneous guy with the right-hand side non-zero. So, step 2 would be to get the two equations for the unknown C1 and C2 there in YH. Those are the coefficients in the homogeneous equation, and that comes from the initial conditions. And then step 3 would be solve that system for C1 and C2 and substitute back in into that general solution. All right, so let's get started with step 1. So YH is the general solution to y double prime plus 4y prime plus 4y equals 0. And the characteristic equation for that, when you plug in y as e to the rt, is you get r squared plus 4r plus 4 equals 0. And that factors, which gives you some confidence you're on the right track. That's r plus 2 all squared equals 0. So this really does have two roots, but they're the same. So we say two roots counting multiplicity. R1 is R2 is negative 2. All right, so the root of minus 2 gives me e to the minus 2t, and the second root gives me t e to the minus 2t. So yh is c1 e to the minus t plus c2 t e to the minus 2t. Or we can also write that as c1 plus c2t all times e to the minus 2t. So I can factor out the exponential term here. All right, so yh has two constants because it's second order. All right, so what about yp? Yp is, well, it has a functional form of e to the t, just like the right-hand side, but I don't know what the constant is in front. So that's the undetermined coefficient a. And this, by the way, follows Rule 1, and Rule 2 does not apply. Rule 2 doesn't apply because e to the t is not a solution found in YH. Okay, and that's on those rules are on the handout that's on the website for the method of undetermined coefficients. So when I plug this into the left-hand side, I want to get, choose A so that I get 18 e to the t. And this is particularly easy one to plug in because yp prime and yp double prime are also a e to the t. Differentiate e to the t, I get an e to the t back. All right, so plug this in to to the non-homogeneous ODE, and I get a e to the t plus 4 times a e to the t plus 4 times a e to the t, and that should be 18 e to the t. So factor out the e to the t on the left side, and I get a plus 4a plus 4a, 4, 8, 9. I get 9a e to the t equals 18 e to the t. So a, therefore, a is 2. And I get yp is now 2 e to the t. All right? Good. So I have, as summarized, I've got yh, I've got yp. So the general solution is y is c1 plus c2t e to the minus 2t plus 2e to the t. That's the general solution to this non-homogeneous linear ODE. It's a solution for any C1 and C2, but I want to solve the initial conditions. So let's do now step 2. Well, let's just write y prime of t underneath that y. Okay, I need to differentiate it first before I set t equal to 0. All right, so when I differentiate this, I'm going to use the product rule. Derivative of the first times the second. That's the first times derivative of the second. Derivative of the first is c2 times e to the minus 2t plus c1 plus c2t. Then I have the derivative of the second. I get a minus 2 from the chain rule, e to the minus 2t. And then I have to differentiate 2e to the t, so I get plus 2e to the t. Back. So now I'm ready to apply the initial conditions. Y of 0 from the general solution is c1 plus 0 times 1 plus 2. Right? E to the 0 is 1. And I'm going to set this equal to 4. And then I have y prime of 0. Okay. A lot of this, right, e to the 0 is 1. Again, that term goes away. So I get c2 times 1 plus c1. That 0 goes away. And then multiplied by negative 2 times 1 plus 2. I'm going to set that equal to negative 1. Actually, I'm going to box that, because that's a system of two equations and the two unknowns, C1 and C2. And now we're going to solve those. Okay, the first one is going to be pretty easy. C1 is going to be 4 minus 2. C1 is 2. All right. And then I use this one, the second equation. I get 2 plus C1 times negative 2 plus 2 equals negative 1. I get negative 2. Okay. Wait a minute. Let's start again. All right. C1 is 2. C2 is unknown. That's actually going to be easier than I had before. All right. C2 plus C1 is 2 times negative 2 plus 2 is negative 1. Okay? So that's going to be negative 4. C2 minus 4 plus 2 is negative 1. Ooh, that's negative 2. C2 minus 2 is negative 1. C2 is negative 1 plus 2. C2 is 1. So C1 is 2 and C2 is 1. Okay? So there's step 2. So finally we get the general solution, the solution to the IVP, to the initial value problem. The IVP is, now I'm going to substitute back in, C1 is 2 and C2 is 1. It's y is equal to 2 plus t e to the minus 2t plus 2 e to the t. All right. And in the box below, I'm going to actually have a link to a Desmos graphing calculator graph of that solution here. And it has sort of kind of an interpretation. If I have y versus t, we can think of the initial condition as a line here giving a tangent line, right? So I've got a solution. The tangent line goes through the point 0, 4. It has a slope of minus 1, okay? And the solution, if I believe, this solution here looks something like this, if I understand correctly. You can look at it on Desmos calculator. And I also have 2 sliders for C1 and C2. So it's initially set with C1 and C2 the proper values to solve the initial value problem, but it might be fun for you to play with the sliders and see lots of different solutions as you vary C1 and C2. And all of those functions that are graphed are going to be solutions to the differential equation, but only the right values of C1 and C2 give you the solution to the initial value problem. All right, well, stay well, stay healthy, stay happy, and we'll be getting back to school soon in wherever we are with our social distance. All right, goodbye, God bless.